Logarithmic equations. These will be some equations of a more complicated format, but remember that in logarithmic equations, your x is in the log and not in the index. If it is in the index, it is an exponential equation. If the x is in the log, then it is a logarithmic equation. And then we aim at getting one log on the left-hand side and one log on the right-hand side with the same basis, important, because if we have log m, okay, and we have got log n, then we can conclude that m equals n, which gives us linear or quadratic equations, which we can simply solve. So the example we have is more than one log on the left-hand side and more than one log on the right-hand side. Okay, our first aim is to get one log on the left-hand side and one log on the right-hand side. And we will get this by applying the log laws. So in this case, people, you should recognize the minus, and you should know that the minus is the quotient law. The quotient of one log equals the difference of two logs, okay? Which means the left-hand side can be rewritten as the log of x plus 3 over x equals the log of 3. Okay, and now people, we've got a single log on the left-hand side, so that basically represents log m, and a single log on the right-hand side, so that basically represents log n. Therefore, we can say that m equals n. Okay, so m equals n. What you really do, people, you just leave out the log. So then we have x plus 3 over x equals 3. And if you look at this again, people, we now got a linear equation, one unknown, and we need to solve for x. All right, we need to find a number value for x. Okay, that means we are going to apply Goro is or. Okay, and I taught you that we will always move the denominator first. Why? Because it's divided on this side and it becomes times on that side, which means I have got x plus 3. I moved this x on the right hand side. I've got the 3, and then I do the so I multiply by x. Okay, now if you look at that, we can just simply move over the x to this side. So again, people, we want to find x. So put the x's together on one side. It is positive. Be careful, people. The x is positive on this side, so it must become negative on the other side. So now I move the x. I got 3 left over. On the right hand side, I've got 3x minus x. Remember, I taught you 3 kudus minus 1 kudu gives me 2 kudus. Okay, and then I still want to know what is x, meaning I must isolate that by moving the 2. 2 is multiplied on that side. It becomes divide on that side. So on the left hand side, I have 3 halves equals the 2 I moved. On the right hand side, I've got x left over. Now once again, because it is a logarithmic equation, you must do the check. Right, so this is my original equation. That's the one that I started off with. So what I will be doing, I will take my answer of 3 halves, and I will substitute that into the place of all x's. Okay, 3 halves. Then I will just take the log, open bracket, the x I replaced, plus 3, close bracket, minus the log of 3 halves, which should give me the log of 3. Okay, if you put the left-hand side into your calculator, maybe I should just show you once again. So we're going to take the log, open bracket, and open bracket, 3 halves, 3 halves, close bracket, maybe I should just show you, then plus 3, close bracket, then we've got minus log 3 halves, minus the log of 3 halves, 3 halves, close bracket, and that equals 0.4, 0.477121, and so forth. Okay, then on the right hand side we've got log 3. So on your calculator again, just press log, then 3, close your bracket, equals 0, let me just do it this way, 0.477121. Okay, and we see that my left hand side is equal to my right hand side, and therefore I know that my answer of x being 3 halves is correct.